Hi, good morning. This is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, in our video lecture series, we are going to discuss about noises in amplitude modulation and frequency modulation receivers. So already we are actually discussing the communication system video lecture series. So this is the unit 2 radio receivers. So how the noise is affecting the FM receiver and the AM receiver, that we will see, and how the solutions, what are the mitigation techniques to overcome these noises that are all discussed here. So let us dive into the topic. So first, let us have some introduction about the noises in AM receivers. So first of all, the noise is nothing but for a good example is when I am talking to you, right? You are hearing. So I will be considered as a transmitter. You will be considered as a receiver. Okay, just one example, right? So when I am talking without anyone other than me, no one is talking, just I'm talking to you means you can clearly hear my voice. But in another scenario, if I am talking to you and the parallelly some 3 to 4 persons are also talking to you means that time you cannot able to receive what I'm talking, or you cannot able to hear what I'm talking. So actually here the my voice signal is the important one, that is a message signal, where other 4 to 5 members are the unwanted one. So the unwanted one will will reduce the quality of original signal, right? So this unwanted signal is called as a noise. Okay, this is the one great example. So noise can be also called as jitter or something, distortion, signal distortion, like that, right? So the noise must be reduced as much as possible in the communication system. That is a very challenging one. Okay, even you can write in research article to how to reduce in the noise in analog communication and as well as the digital communication. It will be a biggest challenges. So fading and small scale fading, large scale fading due to the multipath propagation. So these for these reasons, the noise actually would appear in the communication system. So especially in noises in AM receivers. So actually types of noise affecting the AMs are there mainly atmospheric noise and man-made noise and thermal noise. So what is atmospheric noise? So when you are just imagine, not imagine, you could able to see when you are operating the television in your home, the olden TV I'm telling, the CRT based TV. At the time, it is a rainy season and thunder storms and heavy wind is there means at the time you could not able to see the clear picture, okay, clear video. So that will be zigzag or something like lines will be appear or some dots will be appear, right? Because these are all the things actually the atmospheric factors, right? Atmospheric factor that signal will be affected. So this is the one kind of a noise which affects the AM receiver, and another one is a man-made noise like sparks. For example, you could able to see when you are using mobile phone in closer to your television, the television will give some sound, some beep sounds like that, right? So because here the mobile phone propagates the electromagnetic waves, and also that the television also having the same thing, then that will collide and it will create some sparks or some sounds. These are also called as a man-made noise. And effect on AM is actually since the AM carries information in the amplitude, the carrier wave, and the most noise also appear as random amplitude variations. So AM receivers are highly susceptible on to noise and interference. Right? So so disturbances distort the signal strength, leading to the crack of the signal and poor quality of signal. And let us come to the noises in FM receiver. So types of noise affecting are similar sources, atmospheric and man-made, thermal, like that. But here one of the advantages is in AM, the random noise variation will appear only in the amplitude, where amplitude will be changes. The amplitude changes will be considered as a message signal. But here in frequency modulation, we already discussed the very biggest advantage of FM over AM is here the amplitude remains constant. Only the frequency variations will give you the output result, right? So here, since the amplitude is constant, so there won't be any random variations in the amplitude. So it is less susceptible to the noise or interferences than compared to the AM. So that is the very important thing. And here the results, FM provides much better signal to noise ratio, that is SNR, and higher audio quality fidelity than AM under normal conditions. So why that's why you could see many radio stations using FM, Korean FM, Radio Mirchi, like that, right? So those broadcasting stations which uses the FM frequency modulation because of this one, because the audio plays a very vital role there. There is no video, so if it is video, then AM could be AM must be collaborated, right? But here only the audio plays the role, so they use only FM frequency modulation technique than AM. And noises in AM, DB, DSP, SC receiver is shown here. Bandpass filter and product modulator there. Then the oscillator will gives the signals, carrier signal, and the low pass filter will band limit the signal, and we will get the OA of T. And the noise in FM frequency discriminator method. This is one of the method, right? Here in the receiver section, the FM signal receives the noise which is added, that is summation which is mentioned, the W of T, and the band pass filter will limit the signal, and the limiter is there, and discrimination. So discrimination is separating, right? And band pass low pass filter and output we will be getting in the FM receiver. So limitations of noises in AM and FM receivers are: this is high noise sensitivity, weak selectivity, and capture effect, and higher bandwidth requirement. So comparison, you could see, I said already, the AM compared to AM, the FM have several advantages, but though it has some advantages, that also having some drawbacks. But compared to AM, this FM is good. So the aspect is given: the message signal, main effective noise, noise susceptibility, types of noise prominent, and SNR, signal to noise ratio, overall performance, user cases, everything is compared here. So you could able to get some idea what is the effect in AM and FM in a clear manner. So conclusion, so I said already, the FM provides much better quality and noise immunity compared to the AM, making it a standard for music and entertainment broadcast. So this is the conclusion. And so these are all the assessment questions. You just answer your questions. You just see the question, and there are some the limiter stage in the FM receiver helps to what is that. So the why are AM receivers more affected by noise than FM receivers? So these are all questions. Just you don't try to answer only. You have to give the justification also in your paper. Thank you.